We are deciding which areas can be trimmed down and which we need to add more sections to. Going over last semester's class evaluations, I think we need to take a look at our courses in statistics. You all are my best professors. I understand you have done some research already.
Yes, my colleagues here and I have done our research for our Psychology 220 courses. We administered pre and post tests. We are hoping to find that students were more interested in statistics at the end of the course than at the beginning. So they will want to take more statistics for classes. Students were our population we tested.
What we did was gave each of our students an anonymous questionnaire at the beginning and the end of the class. We were trying to just get a basic idea of whether or not they were interested and if the class improved their interest.
Ideally, what we chose to do is we chose to use a dependent t-test. Primarily, the dependent t-test is used for research studies that want to measure a single sample population before and after being exposed to a certain treatment. For this class, that would be the class itself. Before and after is the treatment. These study designs are known as repeated measure designs or within subject designs. With a dependent t-test, we're taking the nominal variable with two groups usually, but not always the before and after group. And occasionally they'll have situations where they're under different names. For each of these groups, there's usually a method of scoring. These scores are considered an interval variable. For the purpose of this study, it's a scale of 1 to 10 on their interest level of the class before and after. Random sampling, the assumptions of the dependent t-test is that the sample is randomly sampled from an estimated population. For the purpose of our study, that would be a random class of the number of courses that we offered of this course. The scores are normally distributed in the population. Different scores are normally distributed. We were able to get around this by, well, they have to be either normally distributed or they have to have over 30 people interviewed. We had 30 people interviewed. The samples or sets of data used to produce the different scores are linked in the population through repeated measurements, natural association, or matching. So that means that there has to be some kind of connection between the students, the test population of the population 1 and the population 2. We do this by having the students be the same people, the same individuals taking the test multiple times to give two sets of scores. From our test study, we took the scores of the students before they had taken the class, and again, near the end of the class. The variable that we were investigating was the interest level of the class at the beginning and the end of the class. I already said that, so let's just keep moving. As with the statistical test, we had to go through the hypothesis testing, which means that we had to establish a null and research hypothesis for our study. The null would be that there was no difference between the population 1 and 2. However, that's what we're testing against. That's not what we're looking for. The research hypothesis is that there will be two differences. There will be a difference between population 1 and population 2, which means that we've got either the students are going to be more interested or less interested. Ideally, we were shooting for the students being more interested. However, we have to establish the cutoffs, which for a two-tailed test, we needed to determine whether they're more interested or less interested, which means that we had to use the two-tailed test. We used the 0.05 significance level just because that is a standard cutoff value. Degrees of freedom would be much further down on this list, but that's what we got. And here are the results of our test after being run through SPSS software. As we can see, the mean of the students before we took the class was about 5.5, and the mean of the students after the class was about 4.4. The standard deviation being 2.5 and 2.1 respectively. With this, we get a significance level of 0.5%, which means that it passes the 5% cutoff value, meaning that it is statistically significant that our courses were negatively influencing the students' interest in the class. And that's what we have.
So what do you guys suggest we should do about adding or decreasing sections?
I do not think we need to add any more sections of statistics class for students to take.
A trend I noticed is more people seem to be more interested in statistics that could relate to them. So I think we should consider adjusting the courses to have more relatable real-life examples.
That is something I can easily do. I will gather all of our professors that teach statistics and have them work together to update course material. I appreciate you all for attending this meeting and thank you for your